Hello there, my name is Ahmed Hussein and welcome to my channel. In this video, I'm going to demonstrate the server performance behavior and why it's very important to take care of this kind of behavior before going further and building your project. We have a deal that we are going to treat our server like a house. Imagine this house has been built with a very weak infrastructure and there's too many people gets inside this house and the result it will collapse. And imagine if I'm an evil person and landed a flood of requests to your server and bring your server in a crazy mode, let me call it that way, and I flood your server with many requests, so your CPU got been used 100% and the server will going crazy and everything going to collapse and your server will be unresponsive. Let me act as the evil person now. Let me act in a way that I will flood my server and I will write a very bad code inside my Spring Boot without take caring of synchronization or threads or anything related to performance. And let's see what will happen. I'm going to demonstrate this kind of behavior now. Inside my Spring Boot code, we been writing a code that will return a list. Well, let me try to do something different. Let me call it here with a comment. Let me try to make heavy task and let me create an integer value and let me call a while loop. You think of it that way. I would say while I smaller than, let's say, 3000. And let me open my brackets and I plus plus. So we keep looping. Now what I'm going to do here is moving my line. I will add some string to my output. So I will add a line and I will remove this one and I will make it plus my integer variable. And also I want to see the threads that will be used. So I will call it thread plus, let's say thread dot current thread dot get name. These heavy tasks that I just simulate, uh, it may be a database task or something bigger, but I intentionally write this code that way. So I'm going to show you what I'm going to do with my other app that I just created to make a test. So I have built a tester app. Let me show it to you in my OBS. And let me bring it here. And this tester app can be used by an evil person. I mean, if I'm the bad guy and I'm trying to flood this server, let me run my server first. And let me test it in my browser so you can see what I'm gonna do here. You can see I got a couple of lines and you can see my thread number here that been used in the queue. And it uses one thread with the same name until my while loop has been finished. And if I refresh again, another while loop will be done. And if I keep refreshing, I will keep telling Tomcat to create threads or use the pre-created threads in the queue. And it will be going like that again and again and again. What if I decide to do something more evil? In this IDE that you see right now, I use a basic language. By the way, I'm not limited to one language. I get used to write codes in a several language before, so I'm not limited to use Java only. I use Basic, Free Pascal, C++, C Sharp, so PHP, and so on. So I'm not limited to one language. So I built this tool to intentionally flood my server to see what will happen. Let me run this code. And this may be an evil user, by the way. And you can see instantly my server going crazy and I got bad responses. And if I go to refresh here, you can see my server has been collapsed. And if I open my Spring Boot, let me show it to you in the OBS. You can see what happened here. I have too many uh, problems now. So my server has been crashed and collapsed and it's become unresponsive because I intentionally write this evil code and or let me call it a beginner code. So I didn't take care of synchronization and I didn't take care of many requests that will happen in the same time. Let's say I have a million users without bad users intentionally flooding my server. Those many million users will be a bad users for this kind of code. So what I have to do now is figure out a logic in Spring Boot to make my server responsive with too many requests. And in order to do that, I will choose asynchronize uh, method. And this asynchronous behavior that I will use, I will manage my server to run under asynchronous behavior. Regardless the threads that will be created, I will limit it to my server CPU or my machine CPU to be friendly to my machine. So it not exceeded the capacity of my machine, because if your machine get filled with threads and your CPU got 100%, your machine will collapse and it's going to be very slow and may crash. So I'm going to show you what I'm going to do in this kind of scenario. So in this kind of scenario, I'm going to build a service at the beginning, but let me in my basic application, I'm going to enable asynchronize for all my models inside Spring Boot. So I will enable asynchronize and my application will be run asynchronously. So I will control over the threads and I will control over the requests and maybe give the ability to those million requests to pass without problems. But by the way, you have to understand that this kind of code is only for a test. I mean, it's very bad to write your code that way, but I just intentionally routed that way to demonstrate this kind of behavior and to show you what will happen if you follow a heavy task inside your default route that way. But I will create a service. But before creating a service, I'm going to add annotation to enable asynchronize. Let me enable async. Let me import it from my annotation. And I will create a folder and I will name it services. So I will store my services over there. So I will create a folder and I will name it services. And inside my service, I will start to write my code. For example, in my default controller, this is a very stupid way to write a code, but I'm gonna take this code and I'm gonna copy it over there in my welcome service. And this is my default route, uh, and I will name it async. And I will give this method an asynchronize annotation. And how I'm gonna do that? I will only go over there and I will say async, and I'm gonna import it. This will execute this code or this method asynchronously. So it's going to be a friendly with my requests. So let me right now change the behavior of this kind of list. Let me use a completable future as example, or we can leave it right. Let me, 1 second. I can make this kind of method private, right? And I'm going to write another public method, public, and this method will be my threading friendly and run asynchronously. So I will use something called completable future, and I will call the list inside it. So let me say completable future. And this completable future will return the same type of my default route async. So I would write just list and string, and I will give it a name of uh, let me call it call default route. Let me open and close the bracket. And this method had to return something. And as well, this is going to be an asynchronize. So this method would be called asynchronizely. And I already enable asynchronize in my main application, so I don't have to add this annotation inside my service here. So it's going to be applying all classes that will be running in this server. And after that, I have to call a return to return this default route asynchronously. So let me return this method with completable future, and let me call completed future over here. So I will call completed future to call this method of a default route asynchronize. So I will call it right here, the brackets. So after writing my completable future and calling my default route asynchronously, I'm going to auto-wire this service inside my controller. So how I'm gonna do that? Let me delete this trash code and I will call this welcome route. And let me return my method. So you may think that we are done over now, but let me remove this array list. I don't need it now because I don't use this code here anymore. So what I have done now, inside my REST controller, I have inject my service using auto-wired annotation, and you can read about it in the Spring framework documentation. And let me try to run my project. Let's see what will happen. And let me refresh my page, and you can see even more faster it's gone. But you may say or may think that, oh, he fixed it. He made the server responsive. No. Let's try to flood my server again intentionally, and let's see what will happen. So I will run my server flooding tester that I just wrote, and you will see that I got the same kind of error. And it's going to give me the same crash, as you can see. Error, error, error. And let me bring the browser so you can see my server is unresponsive as well. So I don't want to make this video too long. So I have a pre-configured class that will control over my threads that's running in my server, especially to protect my CPU from getting overwhelmed from too many requests, and from protecting my queue from creating threads and put it in the queue unless the previous thread has been done, and this is will overkill my server. So I'm going to use this class that I will post in my GitHub, and you can check it up in the video description. So you can check up the code and you can study it well. But let's go fastly through my code. I just create a Java bean and I name the class a Java bean class, and I name it my executor. And inside my cores, I get the available processor in my machine. And I created a three pool task executor. This is a Spring wrapper around the three pool executor. You can read about it in SpringBoot documentation. And I set the core pool size so my CPU never get overwhelmed with those kind of threads that will have long time to get done, or maybe they never done. So I set a max pool size for my executor, and I set a queue capacity so my queue never filled with threads that will overwhelm my CPU. And I give it a name so I can realize the name in my console when I log it. So here I'm going to reject a new thread creation or putting any more threads in my queue when too many requests happened. All right, and I'm gonna simply print a flu detected so you can see in action in my code. And let me try to restart my server. And let me try to call my browser. And you can notice here, let me bring the browser in front of you. You can notice here that my code is running under my executor, which the name that I define inside my async configure. I call it my executor. You can see it over here. So if I refresh, you can see the difference in performance. Actually, it's getting fastly done. But let me try in my flooding tester that I have been created before. Let me bring it over here in my OBS, and let me run the tester. And you can see it's filled and it's getting filled. All right, but let me try to refresh my page. You can see it's still refresh and I have no problem. And I controlled over this bad flooder. And let me check my console. Let me bring my Spring Boot here. And you can see flood detected. I will post this project in my GitHub. I'm going to post the link in the video description. and you can check my GitHub for these kind of codes, and you can study it later so you can follow the best approach. And regarding these console errors, I'm going to show you in the next video how to control those kind of console messages so you never get like overwhelmed with those messages and get this kind of fear. If you deliver this back end to your client, he will say, oh, there's too many error in my console. What is that? I don't understand it. So I'm going to show you the way to avoid this kind of behavior. Thank you for watching and have a great day. See you later. Bye bye.